Hello, everybody. Sorry for the little delay there. My name is Brian Gardner. Thank you for being here to listen to my talk today. So today I'd like to talk a little bit about test doubles. Now, I've been doing testing on Android since I started. I originally was a Ruby on Rails developer. Now, if you know anything about Ruby on Rails, you know they really like testing. So when I came over to Android, I realized, well, people don't really seem to test their apps that much, which was honestly kind of scary. So I was basically trying to convert whatever knowledge I had over to Android. So I enjoy coming out and sharing a little bit about what I know. This talk is meant to be kind of an introductory talk to test doubles, mostly covering what test doubles are, what different kinds of test doubles there are, what tests you actually use those doubles in, and last but not least, how some testing libraries can promote some confusion in the community because they can mess with the names a little bit. So that's what it's about. Also, if you would like to follow along with the slides, that bit.ly link at the bottom will take you to the speaker deck for this particular talk, so you can kind of follow along on your own. So, test doubles. Test doubles are basically any object that you want to replace in test. Now, that's a very broad definition, but basically that is what they are. You'll see at the bottom there are 5 different test doubles I'm going to be talking about in this talk. These are not things I made up on my own, so don't worry about that. These are actually coming from the X-Unit Testing Patterns book by Gerard Mazzaros. I would definitely recommend reading through that book if you want a very deep dive not only into test doubles, but into testing in general. Just be warned, it is not really bedtime reading. It's basically a textbook on testing. It's somewhere around 900 pages long, and it's very, very dense. So these are the 5 I'm going to be covering for this talk, basically just what they are, what they do, where you're going to be using them, and kind of just know you can mix and match these to meet whatever purposes you have. So before I get into what all these different things are, I'm going to talk a little bit about why you would want to use test doubles. I suppose I should start by saying where you wouldn't want to use test doubles. If you have like a very plain model object that doesn't take any objects in as parameters or dependencies, and the logic on them is very simple for their methods, you don't need test doubles there. You can just test those in unit tests. It's very easy to do. Test doubles come into play, first of all, when your object has any indirect inputs. Now, it's indirect, meaning you are not passing these things into the method call. So maybe it takes in some kind of object in the constructor and then uses that object in the method you want to test to maybe query some data from it. That is a place where you would want a test double, because a test double gives you a point of control in that method, so you can basically specify, this is the data I want to pass in, so you know exactly what's going to happen in your test. Now, on the flip side, you also will want to use test doubles if your method has any kind of indirect outputs. Now, this is anything other than the return value for that method, because it's very easy to test a return value. You just throw in assert and say, hey, this should return this particular data. Indirect outputs are more like maybe you're parsing some data from a web server, and as a side effect, you are sending the user a notification or something like that. You will want to use a test double for whatever that notify component is, so you can say, hey, verify when I parse this data correctly, I want this object to receive this other call. So you'll use a test double for that. And last but not least, slow tests. Now, notice the asterisk here, and I really should have made this a lot bigger, because if you are noticing your tests are slow, don't just start throwing test doubles at it to try and make them faster. There are very specific cases where you will want to use test doubles to speed up your tests, and I will talk about those in a little bit. But test doubles are not a one-stop fix for that kind of issue. So next are the types of tests I'm going to be talking about here. So I have unit, functional, and integration tests. Now, unit tests are when you are testing a single object in isolation from anything else. It should not be talking to any other actual objects in your system. Integration tests are basically the polar opposite of that. Integration tests should be as close to your final production code as possible. You want to try and keep it as realistic as possible so you know your code actually works. And just for me, I say functional tests are kind of somewhere in the middle. Usually I think of functional tests as you have some subsystem inside of your application, maybe a few objects that are working together, and you just want to verify that those objects work together correctly. So it's just kind of in the middle of those two. So as I go through each of the objects, I'll be talking about where that particular mock object applies to these tests. And for the mocking library, I will be using Mockito for this because that's what I'm familiar with. If you use PowerMock or EasyMock or anything like that, it's probably fairly similar. But Mockito is one of the largest mocking libraries for Java, not just for Android. So it is probably the most familiar to the most people. So first off, we will talk about mocks. Now, mocks are probably the most commonly known name for a type of test double. But they're probably also sort of misnamed in some cases. So again, I am using the XUnit testing pattern definition of these. So for mocks, you say, hey, what is a mock? Well, basically a mock is an object that you can configure with its expected method calls and parameters. So when I create a mock email service, you'll say, hey, email service, expect the method call with send email to this address with this content, and then the mock object will basically say, hey, during this test, I either did or did not receive this call. Now, one thing about mocks is that they do the verification themselves. So if the mock object receives a different method call, the mock will fail your test. It'll say, hey, I was not expecting this call, so I'm just going to throw, and you're going to get a test failure because of it. Now, a secondary effect or secondary functionality of mock objects is that they can return values for the methods of that object. Now, I say this is secondary because it's not really its main role. Mocks do this basically so your test can run. So if you are expecting an indirect input from a particular object, you still need to provide that, or else your test is probably going to fail because it's going to say, hey, I didn't actually get any data from this object, and then you'll get null pointer exception somewhere. So you can just return data just to make sure that your test can continue. Now, with mocks, there are two sort of subtypes to mocks. We have strict and lenient, and these names should be kind of self-explanatory. Strict mocks are very particular about what they verify. So if the verification methods you pass in, if they're out of order, it'll typically fail for that. If it gets a call it does not expect, it will fail for that. So you have to be very careful when using strict mocks. Lenient mocks are, as their name implies, more laid back about these kinds of things. If the order is wrong, they typically don't care about that. They will just say, hey, I don't care what order I have, I just got the method calls, so it'll pass for that. They may tolerate unexpected calls, so if you didn't configure it to expect a certain method, it might let that pass just fine. So you just kind of have to pick which one you want to use for your particular test case. So mocks, where should you use them? So I'll go ahead and start with unit tests. Well, unit tests, you are testing one object in isolation from everything else, and mocks are made to test those indirect outputs. So this is a great fit for your unit tests, so I give it the green light here. You basically will pass in a mock object to your system under test, and if it has that output correctly, then it's going to pass your test. Now, functional tests are a little bit different from unit tests because it is a group of objects. It is a subsystem in your application, but I will also give the green light for the functional tests because you can typically use mocks at the boundary of that subsystem. So if that system needs to interact with some other system in your application, you will typically want to verify that it's calling the method correctly on that other system. Now, for integration tests, remember I said that it needs to be as realistic as possible or as close to your application code as possible. So you're not going to want to use mock objects for your integration tests. If you need to provide any other data for your integration test, you're going to want to use some other mechanism in order to achieve that. So yes for unit and functional, and a no for integration. So this leads me into how Mockito declares its mocks. And with Mockito, since mock is in the name, it does in fact have a mock method. This is a static method on the Mockito object. Basically how this works is you pass in the class that you want it to mock. It creates an empty implementation of that object and basically puts in some logic to count how many times your methods were called. It records what parameters were passed to that method. So then at the end of your test, you can verify that, in this case, the add attendee method was called on my attendee store. Now this deviates a little bit from the definition of a mock because by definition, you're typically supposed to add your validations at the beginning of the test. So right after you create your mock, you would typically add those validations. But Mockito deviates from that a little bit and just has it do all of that at the end. So next up, we have stubs. Now, stubs are also one of the most commonly used test doubles, but they are probably one of the most misnamed. And you'll see why in just a minute. So stubs are responsible for returning values in a test. That is their whole job. You basically will create a stub object, and they are responsible for handling those indirect inputs into your application. So if I am using an object that uses my attendee store, I will want to create a stub attendee store that returns some data that I can use in my test class. Now, stubs cannot return anything that you don't specify because they're not that smart. They basically just kind of return any values you create. But stubs will also not record the number of interactions that they receive because that's not their job. They don't care how many times a method was called. They just want to return their data. Now, like mocks, stubs also have several subtypes. So stubs, we have responder, saboteur, and temporary. Now, the responder type is basically used to test the happy path in your application. So you're giving back valid data and you want to test that path in your code. The saboteur is on the other side, so you want to test the unhappy path. So you want to throw an exception. You want to return some invalid data. So a saboteur is the name for that type of stub. Temporary test stubs, not super relevant for testing itself. Temporary test stubs are more relevant to a test-driven design type of environment where you know there's some kind of role in your application that hasn't been fulfilled yet, but you don't have a name for that role. So a temporary test stub is used in your actual production code to return the data you need until you figure out that role. Once that role is figured out and you have a class for it, you basically delete the temporary stub because it's not needed anymore. So just like the mocks, we'll see where we can use our stubs. So same way with the unit tests, if your component has any sort of indirect inputs into it, you're going to need to use a stub for that. So we give it the green light there. Functional tests the same way. If your system or subsystem in this case needs any kind of information to be passed in from that boundary, you're also going to need to use a stub for that because it's very easy to control. So we'll give it the green light there. And again, with the integration tests, since this is supposed to be as close to realistic as possible, stubs aren't very realistic, so we go ahead and give that one the red light. So next we have Mockito stubs, and this is where some of the naming issues come into play because Mockito does not have a stub method. Mockito has a mock method, so you can create a mock, but in this case it functions very similarly to the stub object. So not only can you verify that a method was called on it, but you can also say, hey, I want to return this particular bit of data. Now the exact syntax for that, they use a when then return syntax. So when this method is called, then return this data. That is for the responder type of stub, but if you want a saboteur, there's also a then throw. So you can say, hey, when this method is called, let's throw this exception so we can test that error condition. Next up is spies. So spies, honestly, probably not one of the more commonly used test stubs, but it is useful to know about them, just in case you ever run into a use case for them. Throughout my 5 or 6 years of Android development, I've had to use spies maybe 3 or 4 times. So not very often, but they are very useful when you need them. So what is a spy? Well, the easiest definition that I could come up with a spy is they're kind of a combination of a mock and a stub. A spy will basically allow you to configure what data you want to return, and it will also record the method calls for you. The main difference is that spies do not only record the method calls, but they also typically record other information. One common example I hear is that if you have a spy email service, inside of your test, if you want to say, hey, I should send 10 emails with this email service when this thing happens, instead of adding 10 verify calls where it says verify, send email was called with this data, and then verify again and again and again, the spy will basically give you access to say verify 10 emails were sent and verify it was sent to these addresses. So it just makes it a little bit easier to verify that data instead of having to basically declare everything in order. So yeah, also allows you to verify method calls, so very similar. So this leads to where should we use it, and if you've been following along, you probably know where this is going already. So since it is a combination of a mock and stub, you can test the indirect inputs and outputs in your unit test, so we give that a green light. Same way for functional tests, since you can test at those boundary layers, we give it a green light for that, and we give it the red light for integration test because it is not a production object, so you shouldn't really use it there. So this leads me to Mockito Spies, which is one of the weirder things for Mockito, personally, I think. So if you've been following along, I said a spy is a stub and a mock, and you could say, well, this mock thing is basically a spy then, because I can create this, I can dictate what data I want to return, and I can verify the method call is coming out. And you are technically right in that case. The weird thing with Mockito is that it also has a spy method. And this deviates quite a bit from the definition of a spy. Instead of passing in the class that you want to spy, you have to pass in the actual object you are trying to spy on. You can still basically override the return values for the methods here. So when the getAttendees method is called, I can say, hey, don't call through to the actual implementation of this, but return my test attendees instead. You can also verify whatever methods are called on it with whatever parameters. Now, the reason Mockito does this is because they want to allow you to test things with side effects. Now, when you're using a mock objects, there are no side effects at all. So if you mock a array list, for example, if you call add on the array list several times, when you call like get items from the array list, it will still be empty. Or if you get the size, it will be empty because it's not actually doing anything to the mock object. Spies, on the other hand, at least Mockito Spies in this way, they do allow for side effects. So if I mocked an array list, when I added items to it, if I got the size, it would tell me exactly how many items I added. So this is very useful, particularly in functional tests, if you want to verify that subsystem is working, but you also want to verify the state and you want side effects to be in play, you should definitely use Mockito Spies. So it deviates a little bit from the definition, but it is still very useful. Yes?
Are the original methods also called? Like if there is a getAttendees method and you're faking the response, but when it is called, is it faking the response and also calling the real one?
I don't believe the actual method gets called there. I'm pretty sure it just uses whatever pre-configured value you have.
Basically just overriding whichever methods of the real object you want and leaving the other ones intact.
Exactly, yeah, so in this case for my spy store, I would basically override the data that I want it to return. So I don't want to have to go in and say, pull down data from a database and configure all of that data because that would slow down my tests a lot. So I can instead say, hey, just override this one method and then leave all the other methods alone. So it just makes things a little bit faster in that way. Next, probably my favorite name for a mock object, and this is dummies. And dummies are probably the easiest to understand mock object. And that is because, well, what is a dummy? Well, they don't actually do anything in your tests. They just kind of sit there, and basically their role is they fill parameter lists. So if you can't pass in, say, null for a parameter or something like that, or if it's required, you basically make a dummy object and pass that in instead. So where should you use it? Again, unit tests, if whatever code path you are testing does not use that parameter, then it is fine to use dummies in that case. So I would give that the green light. Functional tests are a little trickier because functional tests are more subsystem related. So you're saying, hey, when these objects are working together, they should do these things. So I give this one kind of a maybe. If you're doing a functional test, most likely you won't run into a case where you need dummy objects. You should probably pass in the real implementation. But if you do run into it, that's perfectly fine to pass in a dummy object. And then finally for integration tests, going to give that one a red again, just because, again, you are supposed to be testing your app from top to bottom, from your UI all the way down to your business logic models. So dummies don't really fit into that area. Now for Mockito Dummies, it doesn't really have a dummy method either. So again, we use the lovely mock method. Typically what you'll do in this case is you'll just name it dummy, so dummy attendee or attendee dummy, one of the two, just so it's like, hey, this is a dummy object, don't actually use this. One other way I've seen of doing this is by not using a mocking library, but by creating your own actual dummy class. I've seen people basically throw exceptions for all of the method calls there. That's a little extreme to me because it's basically saying, hey, if this object is ever interacted with, your test is going to fail. I guess if you want to have that kind of confidence that it's not actually used, that's fine, but in most cases, you're probably just going to want to pass in the Mockito version instead. And last but not least, we have fakes. Now, fakes are interesting because they don't really fit like the other test doubles we've seen so far. And you'll see what I mean in just a minute. So fake objects are basically, they are real objects. They are actually a Kotlin class or a Java class, but they are a real object that you want to use in your test. Now, the job of a fake is to replace one of your real objects with another implementation. So your fake version will typically implement the same interface as your real version, but it will basically just give you the speed benefit to it. The most common fake you'll typically hear about is a database fake, where you have some database component that hits the database, it's reading and writing to the file. You want to pass in a fake implementation that does it all in memory. So it basically will give you a huge speed boost, upwards of like 10 times as fast. So this is very important when you, say, have a large integration testing suite, for instance, and you want those to run faster so you can run them more often. You'll want to provide a fake for that. So where should you use it? Well, it's not so good for unit tests because you'll typically want to use something like a stub or a mock for that, because then you can control the inputs and outputs. You can't have that much control for fakes, really. So typically you're not going to use fakes for unit tests. You will, however, use it for functional tests. So if whatever subsystem you're testing is hitting that database layer, you can provide the fake version and it will give you a speed boost there. Same way with the integration tests. You do have to be a little bit careful with integration tests, because if you start implementing too many fakes in your integration test, you're not really testing your entire system. You're testing kind of a fake version of your system in that case. So you just have to be kind of careful. The way I've seen people typically use fakes is they will have some of their integration tests use fakes. Those are the ones that they will run the most often. And then they will have other integration tests which truly test their entire stack, but they aren't run as often. Maybe those are run overnight since they're going to take so long. So if you have a nightly build like that, you can run your entire suite with those real integration tests just to make sure that everything is truly working as you expect. Which leads me to Mockito fakes, and well, Mockito doesn't have any kind of concept of fakes, because again, they are a real object. You're going to need a real Java or Kotlin class for that. So Mockito does not have that bit of functionality for you. So recap, most important 3 things. Number 1, make sure you use the right terminology when describing what test doubles you're using. Even in your test, do not call everything a mock, even though Mockito tends to. This is one of the big reasons that I think there is so much confusion over test doubles, is because a lot of people, when they come to testing, they just hop in with something like Mockito, and then to them everything is a mock, because that's what Mockito calls it. So if you are talking with your coworkers, if you're naming your variables, make sure you use the right words, because a mock is much different than a stub, just so you can get your point across on what you're actually trying to test and what kind of behavior you're expecting. Make sure you match your test doubles for the appropriate tests. Don't start sticking mocks and stubs into your integration tests, because when something breaks, you're going to say, well, my test case is passed, so I don't really know what happened. But just make sure, again, if you're using your test doubles in the right tests, you will have more faith in your tests for being correct. And last but not least, do not overuse them, which kind of leads me into my next point, in that there can be some issues with test doubles, particularly with overuse. Now, what happens when you start overusing test doubles, which is very easy to start doing, I know I've done it and honestly still do it at some points, you get what is called overspecified tests. This basically means that instead of testing what your system under test is trying to do, you start testing the implementation that you are basically using in your test. So you're basically saying, first, my object has to do this, then this, then this. So this can lead to a lot of fragility in your tests. You can change something in your object under test, which can break a completely unrelated test case. So when you see something like that happen, it's going to be very painful, but you're going to have to go into your tests and start refactoring them to actually test what that object is doing rather than how it's doing it. So test doubles can be good, but like anything, doing it too much is probably bad for you, so just be careful. So last but not least, the who am I? So as I said before, my name is Brian Gardner. So that is my Twitter handle there, Brian Gardner ATL. I am from Atlanta. If anybody else from Atlanta is here, I kind of doubt it because it's a little far away. Again, that bit.ly link is for the slide deck, so if you want to check out the slides after the talk, by all means. But as for myself, I work for a company called Big Nerd Ranch. Some of you may have heard us from our technical trainings or our books that we put out. So I am an Android developer and technical author for our advanced Android class, but I also teach our essentials class. But we have a bunch of classes and things. We also have a Kotlin class coming out, so we're very excited about that. So if any of you would like to talk about test doubles afterwards or talk about technical training, please hit me up. I am open to that. So does anybody have any questions about test doubles? Yes.
So my question is, why do you think we can't use spies in integration tests? So imagine sometimes we want to do integration tests on the whole flow, and usually like the very last mile of it will be something deep into Android core, when we can't like actually guarantee that we can get something that we can actually verify actual method value. But with spies, and spies are actually designed for it, we can at least verify that we call proper method, we pass proper value to the system, and then like we can only rely on system to be working.
Right, so using spies in integration tests, just if you are verifying that method calls are made, I think that's probably fine. Just that, like you said, if you're calling to the system and you want to verify that you're making the correct system calls there, that is good. But the reason I said to normally not use spies in integration tests is because a big part of spies is to basically change what it returns. And if you're changing what the values get returned, then that can be a little dangerous in integration tests.
I think usually spies are not used to change what we return, but just to do something on stuff we can't mock, like to verify calls on final classes or something like this.
You could possibly do that. One big thing about test doubles is typically you don't want to mock things that you don't really own. You can get into a little bit of danger there, but if you do find a good use case for it, then I definitely wouldn't complain about mocking the file class to verify.
Hello. Yeah, so for Mockito, how do you specify if a mock is, or how do you configure it to be either strict or lenient? Because I've been using it and I think by default it's lenient.
Yes, Mockito Mocks are by definition lenient. I don't believe there's a way to make them strict. The only thing I've seen is they do have a custom rule you can do where if a mock is unused, it can throw an exception for that. But as far as I know, you can't make them actually strict. If you wanted to do that, you'd probably have to write your own custom mock object.
Hey, thanks for the great presentation. One question that I had was, you mentioned mock objects can sometimes return values in order to sort of make the code under test run. That sort of makes it sound a little bit like what you described in the case of a stub. So can you speak a little bit to how to think about returning values from mock objects versus using stubs and how to differentiate the two effectively?
Yeah, so I think the way Mockito typically differentiates that is when you mock an object, it creates an empty implementation of that class. So it adds some counting for how many times the particular method was called, and it checks the parameters like that as well. Now, for returning values, mocks will typically only return the default value for whatever your return type is. So if you return an int, it should return 0. If you return a Boolean value, it should return false. So anytime you get away from returning those default values, that's where you kind of get into more a stub type of object. Because, again, mocks are just returning things to make sure that the class keeps going. Stubs are more for actually providing that necessary data.
So I was just wondering, in unit test, so normally how often we use the mock? Because recently I'm searching the topic and I found that there are two groups in debate. How often?
Right, so there are kind of two classes to, especially with test-driven development, like the classical test-driven development where you don't use mocks at all. There's also the mockist version where you basically use mocks for everything. Personally, I'm more on the mock side, so I will typically reach for mocks instead of other actual objects. They just make it easier to verify, hey, this particular value was returned, especially if you want to check what kind of parameters were passed in. Mocks make that extremely easy to do. But again, it is very easy to overdo it, so I do have to sometimes rein myself in and say, hey, I probably shouldn't use a mock here, because again, I start to over-specify my tests.
So thanks for the presentation. Quick question is, considering a spies take up on a real implementation in order for it to really kind of wrap around it, and as far as I can remember, you can even call real objects on that. Would you consider basically instantiating a spy on top of one of the fakes that you mentioned, just in the scenarios of the real implementations being like too dependent on Android components, so it wouldn't really run on unit tests.
I think that's a good case, especially if you notice whatever real object you are trying to wrap is slow, like the database implementation, for example. I think spying on that fake version would be just fine, just to say, hey, verify that this particular method is called. And then as long as you have like really good unit tests around whatever object you're replacing, I don't see any issues with just wrapping the fake with a spy.
Okay, yeah, I wasn't sure if it was a limitation of the Mockito framework, potentially.
No, yeah, Mockito can mock and spy pretty much any class or object you give it.
Hi. Quick question, we're using RoboElectric currently and trying to get away from it, especially for testing logic in our activities. In theory, we should be able to use mocks to inject all of the inflated views we have and then run a test on an activity using only mocks, or is that going to be limited because you can't mock final classes?
So actually in Mockito 2.10, I believe, or Mockito 2, whenever that came out, you can actually mock final classes now. That was kind of the big thing they added for the next release. So you can mock those final classes now if you need to. But I have definitely gone down the same path. I started using RoboElectric when I first started testing, and testing your activities is quite a pain. So I would do basically that. I would have like my custom view objects. I would mock those out, pass them into the activity, and then just verify the right calls are being made on whatever actions, just to make things a lot easier.
So you can do that without RoboElectric if you use mocks properly, right?
I believe so, yeah. Having your activities run, though, can be a little bit difficult without something like RoboElectric, but I've definitely seen it work that way, yeah. Mm-hmm. All right, well, if there's no other questions, thank you all for coming to my talk. I hope it was helpful. And if you have any other questions about test doubles, feel free to hit me up during the conference. Thank you very much.